Good morning, good evening. So, welcome to the third part of MLOps by using MLflow. Previous two videos we have seen the introduction of MLflow, what are the components involved in MLflow. And the next we have seen one of the major components which is called MLflow tracking. So today we will be seeing MLflow registry. What is the importance of MLflow registry? And then the different aspects of it, and then how do you consume the models once the model is registered, and then how do you version the models, and ultimately once you are satisfied with any one of the model with the kind of desired results it gives, and finally we promote that particular model into stages, like it could be a staging or a production. So we call this as different stages that we put the model into. So we see all these things in this particular video. So without any further delay, let me start. So I won't be explaining the model building part again and again. If you need the model building part, you can visit the previous video where I have explained what exactly I was doing. So I just go through it now, and then we actually start the content from the model registry and then model consumption part in this particular video. Okay. Just before that, I am here with the database. So if I refresh, I don't have any tables registered inside my database. So for that, like, let me run the MLflow server. Okay, and then it's been registered on 3000. So once done, just refresh it. So you got 12 tables. And then let us start querying and then see that this particular database is empty. Okay, there is no here. Query console. Okay, so we'll say select star from runs. So there are no data, no rows available. Same time, select star from experiments. So there is one default experiment which is like by default it gets created once you run this MLflow. That is, if you just refresh this, I'll show you that from disk. Okay, that is because of this MLflow runs. So this MLflow runs get registered as a default experiment inside our MLflow database. Okay, so with this, what we'll do again, we'll even open the web and then see this default which is shown here, experiment. So you can see there are no runs actually. So that's what I was telling. So once this MLflow server runs, it creates this MLflow runs directory, and then that is registered as a default experiment, out of which that default experiment you don't have any runs under that actually. Okay, so now what we do is, let me start with the experiment, and you obviously know that we are dealing with the iris dataset in this particular series of ML ops. So let me quickly run, and then I'll stop this running of notebook exactly at the time when we start MLflow part of it. So now if you see, my Jupyter notebook has been started. For now I'll minimize this. So MLflow starts from here actually. Okay, if you have went through my previous lecture on MLflow, so we have created one small method which is called start experiments, out of which we are passing a few parameters into that particular method, which is called experiment name, run metrics, model, run parameters, tagging and everything. So what we'll do is, I'll show you something. I've just made a few modifications here. We are registering the model here with something called two specific parameters, which is called registered model name and then signature. I'll show what if suppose we don't do this and we do that. Okay, I'll show you the difference exactly, what is exactly happening with those. Okay, and then let me comment out this as well, and then I'll open this, and then this tag I'll name it to string, and we are actually following the Python 3.9 specifications, where you can actually attach the data types for the parameters such that like you get the compile time errors. Okay, so if you see it here, it clearly says that expected is type string, but you are passing a dictionary over there. Okay, so I'll just comment out this and I'll open this. Okay, and now let us run this and run this. Experiment name is not defined. Okay, fine. I think like we did not run this. Okay, we run this and then we run this name, and then we run this. Okay, now experiment is being created. Now it said like it does not exist, and the reason like it created it. So let's go here and then refresh it and see the basic is created. So if you go here, so in the models, if you see the icon here, it is like sklearn. Okay, and now for the basic, if you go here, the tags whatever we passed in, right? So so we attached the tag that we passed here, which is like the tag name is basic decision tree classifier, and we are attaching that to the key or a name which is called tag1. So that is here. But what if suppose you want to tag this particular model multiple with multiple names or multiple keys? Okay, so you can have a model attached to multiple tags. So which like our start experiment method or tracking of the experiment, this is not suitable. So I just made a small tweaks to it such that like it supports more dynamic way of passing tags and all. Also if you see it here, if I went here, what it is telling you is like it is tracking all the artifacts which we know, which we all saw it in ML tracking. At the same time, if you see it here, we are getting something called register model. So this model is not at all registered, it is just getting tracked. Okay, if you click on register model, so it will ask like manually create a model and then register it, all these things it will tell. If you go here here and then go to the models, so there is no model that is being registered actually. And then here also there is something like you can create a model, and this created model you can actually register here, going here actually. So if you click on this, so that particular created model will come inside this particular drop down, if at all that is done. So this is all manual activity, but we don't want to do this manually. So everything should be programmatically driven. So as soon as your experiment is done, you should see everything flowing down into the MLflow. That gives you more flexibility, maintainability, right? So now let's do that and then see what exactly happens. Okay, so now let's do the changes back, revert the changes, and then see what are the tweaks here. Okay, so I'm doing just Control Z. So I'm passing the tags as a dictionary. Now it becomes a dictionary. So since it is a dictionary, I am actually iterating through the keys of the dictionary and setting the tag, and my tag I'm passing the key as the dictionary key and the value as the dictionary value. Okay, at the same time I'm doing my log model with two extra parameters, which is called register model name and then signature. Signature is basically, if you don't pass this signature, okay, let me do that as well. Okay, let me copy this and then come here, and then I'll delete this. Okay, so with this what will happen, I'll show you. So now let's run this particular run this start experiment, and then again you do this. So it will say that it will be created one more run. Okay, so now go to the experiments and then the basic. So now you see there are two different runs under the same basic decision tree classifier itself, because what we are doing is the run name is same, the run name we are not changing. Okay, so your experiment is same and you are actually getting two different runs, and even the run name is also not changing. Experiment is also the same because we are actually creating a decision tree classifier. So let's open this, and if you see this model icon here, did you observe this variance or the difference? So this is just like, it says like sklearn, which is like model got it's like model got tracked, but it's not registered. But here this model is registered. Okay, the reason for that is this one. So the registered model name. Okay, so if you pass this registered model name, it will register the model which is getting tracked also. So you just go to this and now you see this, there is no register model button, but in fact it is saying iris classifier version 1. So it has given version 1 to this particular model, and it is already registered inside the models. So now if you see this, the name is iris classifier latest version. And I was talking about in the initial stages of this video, it's about the stages, right? So these are the two different stages. Like you can push this particular model once you satisfy with the results, which is called staging and production. You can push this into staging, test it, and if still the results are better, you can push it into production mode. Okay, so now if you go into this particular thing, and there is no tags attached to this particular model, but in fact we have tags for the experiment but no tags for the model attached, that also you can do it. But at the same time, if you click on version, there is a schema. Okay, schema means like what are the inputs that are getting passed into this particular model, what is the output that is being expected out of this model. So that is what the schema is meant by. So that we don't have it, and in fact it is saying no schema, please follow these docs to include the input and output schema models for this particular version 1 model. So to do that, we just need to pass this signature. Okay, so if you pass that signature, what will happen is it automatically identifies what is the inputs that is being passed to this particular model and what is the output that is being exposed out of that model. So everything is being tracked by the signature, and that signature eventually will put the schema inside that web console. I mean web console is here. Okay, so what we'll do is now let's run this again. Okay, and let's do the advanced model, and such that like you can even see the tags, even the different parameters as well as the schema. Okay, so let me run the advanced model. Okay, so it is running. Okay, it's almost like 97.09 97 percentage, 97.1% in fact. Okay, so let's do it, and then let us run. So it created a version 2 of it. Let's see, go to the experiments. So it created an optimized decision tree. Let me go here. Okay, click here. Now it is also like registered model. Okay, you click here, so it says like version 2 has been registered, and then your metrics are tracked, and the tags, if you see, there are two tags. Like I tagged it with two different keys, advanced experiment and optimal experiment. Okay, so if you see my experiment calling, so I just called it with a dictionary with two different keys. At the same time, if you see, there is a signature that's been inferred. So there is a method called infer schema from the MLflow models module. So you pass the training, and then you just predict with the X test data. So when you pass the training dataset and test dataset, so it will infer what exactly is being taken as input and what is being exposed out of it. So that it will take it as signature and it will register. Now I will show you how it looks like. So let's go to version 2 here. Okay, directly you can click there and it comes here. Now if you see this inside schema, it says like inputs. So you need to pass sepal length, sepal width, petal length and petal width, and output would be a tensor. So this is what we need it, right? And moreover, again, if you go to the registered model, so you have version 2 of iris classification, because the name is same, so it has overridden version 1. Otherwise, like you would have two versions, like version 1 and 2. Okay, so with this I'll stop here, and then we'll go back and then see how would we actually take the advantage of the tracked model and consume that particular tracked model. Okay, let's go to experiment back. Okay, and then go to optimize decision tree. Okay, go here, and then you inside the track artifact tracking, if you see this particular section, this is the usage. Like you can use this particular model inside PySpark ML and or normal pandas way of utilizing or consuming it. So in this I'll try to get it from the pandas, but whereas Spark ML we'll do it when we are actually dealing with the Spark series. Okay, because I can't run both Spark as well as MLflow on the same thing because of a resource overhead. So I'll try to run it from the pandas data frame. Okay, so it is I already coded that. Okay, what we'll do is now we'll just change this run name. Okay, and then we can put it here. Okay, and you just run it now. So once you run it, so you have the predictions of your X test. If you see this, the model input for the model, the input would be the data. So the data is X test. So I pass the X test, and finally you have the prediction. So I just outputted the first 10 predictions of the actual predicted output. Okay, and yeah, you can even do for the basic model as well that we have. Open the console and then get the basic model from our experiments. This is the basic model. So this is the latest run for the basic model that we have done, right? So let's copy the run ID and go back to the code, replace it with this, and then try to run. In this case, what we are doing is we are not passing the whole X test, but what we are trying to do is assume that you went and measured explicitly a few of the parameters of a flower, and then you are passing that, and you are trying to predict what exactly and which category it belongs to, that flower belongs to. Okay, so if you run this, so it says like it is I'm sorry, let me scroll it down. Okay, it says versicolor. Okay, so iris versicolor. So these kind of readings would categorized into iris versicolor. So this is how we can do both. So if you want to consume the model, the advanced one or the basic one, you just need to grab the run ID and then get it. What if suppose you don't have the run IDs, or you are not able to grab it from the web? So you can always go into the database, and let's go to the console and then see the runs here. Okay, see this the default one and the other two runs that we have here. Okay, so you can grab the run IDs, and then you can just replace into your model consumption, and it will start consuming up. And there is another way of consuming a model as well, which is called PyFunction method. Okay, this is the run ID method, and the other one is the PyFunction method. So this is how the PyFunction method would look like, where we will get the PyFunction from MLflow PyFunction. We just named it as an alias, which is called PyFunction. At the same time, we have something called MLflow sklearn, and then there is something called load model method. Okay, out of this module. And now our let's go back to the web, and then we'll see the registered models. So for the you can even use it from the registered model also. Okay, so registered model, the version is 2 basically, right? So it is like, if you can see in the top, so the name of the model is iris classification and version is 2. Okay, so just go back here. So my version, I say 2, the model name is iris classification, and this is how you need to load a model using PyFunction. Okay, PyFunction.load models, and model slash model name slash model version. So this particular version would get loaded. Let's suppose in the long run you did a lot of experiments, a lot of runs to get the desired output or the desired results or desired accuracy. So you may end up with a lot of versions, right? So out of which, like, you can actually fetch one particular version and then run it. Okay, so now I'm running it. Now you can see it. These are the predicted probabilities, and these are the predicted categories. Okay, so both are actually depicted here. So to do a predicted probability, there is no direct method available. In fact, what we are doing is sklearn models dot predict probability. So that is where it is there. In fact, it is not there inside the MLflow PyFunction or MLflow something like that. So we just need to do a sklearn model dot predict probability of X test. The sklearn model is coming from the load model. Okay, load model is from the MLflow sklearn. So it is not there in PyFunction, but there is a separate module like MLflow sklearn, out of which you can get the prediction probability. Okay, so now we know how to register a model and how to consume a model, both like from the tracking artifacts, or if you pushed into or if you registered that model with a specific version. So with that particular version, how to consume or utilize that particular model, that we know. but how to promote a model. Okay, so that we will see it. So we have something called MLflow tracking, MLflow client. So this MLflow client has got a method called transition model version stage. So it says like iris classification version 2. Currently we have version 2, right? So this particular version I want to it is pretty decent, so I just wanted to put it in production. Okay, so go back here, you say just production here and then just say run. Okay, now go back here and then just refresh. You see this version 2 is in production now. Now if you go here also, it say that version 2 is in production, and version 1 it is nothing else, the stage is in production. So now let's go here and then you can give the version 1 as I'll just do a control Z such that like it will come back. Okay, now you run it again and go back here and then say refresh. Now you see version 1 is in staging and version 2 is in production, and go back here and then you can even access again back with version 1. Now if you see version 1, which we are accessing the version 1 from staging side. Okay, now if you run, so the prediction probabilities and prediction classifications. So this is how we can do it. The next part of this or the extension of this would be how do you serve this model inside a production. So out of this model, so now you know how to register, track it, how to push that into different stages like production versus staging, all these things using an MLOps or MLflow basically, right? So ultimately at the end of the day you have to expose this model to some third party client APIs or client apps, right? So that would be done something like this. Let me open my architecture diagram. So I don't have it, but if at all you really want it, please put a comment in the video section. Then we'll create one separate video for this, how to create a fast API or a Flask API and then consume the model and then expose it as a REST APIs. Okay, that is a separate altogether track, because most of the coding part would be on the website, not from the machine learning or MLflow or MLOps side. So that's the reason I'm not including in that this particular aspect into this series. But if at all really needed, please put a comment and then we'll definitely create a video for that. So what it would look like is, now you have the model already and we consumed that particular model as well, and there is a versioning strategy also been defined for this particular ML model. Now you can choose any of the frameworks like a Flask framework or a fast API framework, and using these any of the framework, it can take any one route. So you create a Flask API, access the model and then expose as a REST API, and the client API client apps can consume that particular model using the REST API. Otherwise it can take another path where you create an APIs using the fast API framework. It will consume the model based on the inputs and finally produce the output, the predicted output, using the REST API. So any one path it can choose and then fulfill the goal of your end-to-end machine learning lifecycle, right? So if you really need it, just put a comment and then we'll really do this video and then post to you guys. With this, we are actually ending the series of MLOps. So from the starting, we understood what MLflow is all about, how it falls under the category of MLOps, and then we went with the different components of MLOps, and then we saw tracking, we saw registry, we saw model serving, model access, model versioning, and model registry. Okay, so please share the feedback, share this video, like, subscribe, such that like we get your support as well as feedback, and then we continuously improve the content of the videos. Thank you very much.